Well, good morning, everyone. I'm Aaron Johnson, the Executive Director of the American Institute of Professional Geologists. I'd like to welcome you today to our AIPG Lunch and Earn webinar series. Just a couple of quick bookkeeping notes. If you need continuing education credit, we will send that certificate to the same email that you used to register for the webinar. It's automatically generated, so you won't need to make a request. Do watch for that in your email, and if you don't receive that, then reach back out to us and we'll ensure that you get the certificate that you need. Also, remember that if you need CEUs for your professional registration in New York State, you will have to complete a 5-question quiz at the end that is content-based. This is a requirement of the New York State Education Department. That quiz, the link will be posted in the chat, so watch for that at the end of the webinar. We'll post that a couple of times so that you don't have to scroll too far down to find it. It will stay open for about an hour, and you can take that quiz as many times as you like until you get the requisite 4 questions out of 5 correct. Well, today it is my pleasure to introduce our speaker. I could talk about Tom Herbert for an hour and still really not do his career justice, so I'll try to limit my remarks just a bit. Tom has his professional education from Michigan State University, both in geology and in resource development. He's been a CPG for more than 50 years and has worked in a really a broad spectrum of different sort of career paths. He's worked in aggregates, oil and gas development. He's also worked with the state legislature to really look at water resources and mining and oil and gas, especially in coastal areas. He was one of the founders of the Florida Association of Professional Geologists, and he served as the chair of the Professional Geology Board in Florida. In addition to all of that, Tom is a wonderful role model, mentoring students both in the U.S. and abroad, and comes from a long line of family members that, as he would say, look into dirt and water issues. Tom, it really is a pleasure to have you here with us today, and the floor is yours.
Thank you. Thank you, Aaron. I appreciate the time and the effort here. This has been one of my long-standing goals, is to push professional geology forward. Many of the states require a continuing education component, which I heartily agree with, and encourage people to participate and do things in that area, because we're stuck in time. I think when we go to school, I noticed that when I was back in the 60s, and the field has changed incredible because of technology and communications and more tools and Google Earth and things like that, that you can get a more synoptic view of the planet and see what's going on. I think that's critical. I labeled the talk today "Trouble in Paradise: Geohazards in Florida." It's kind of tongue in cheek, because we don't really have trouble in paradise. It's just we have a lot of expensive things going on where people have moved to the state and are living here, and we're interacting with potential geohazards all the time. And I think we will, as we go through the slide deck here, we'll go through and talk about a number of these issues. And what's incumbent is that the professional geologist, as a trained professional in understanding the earth processes, and if those individuals, those PGs, are willing to step out and communicate, they can be a real asset to the public, who are, as we all know, are being besieged by media that is probably a little bit off base in many cases, where they're seeing geologic events as something special or new or unexpected and unanticipated, when in fact we as geologists, I do kind of, when I read this stuff and somebody asks me something, well, so what? What's the big deal? We already know that. You just have to apply it. But from a geohazard standpoint, if you are presented with a series of geohazards, it's good to understand them. They are important in the financial world. and investments, particularly here in Florida. We'll get into that. But the other thing is that, you know, there is the human health and safety issue, which there can be issues with that if you're in the wrong place at the right time. So with that, let's go forward here. Quick background, Aaron went through it. I've been a geologist since '66, a lot of experience in mining. And in coming to Florida, my CPG story is that I came to Florida in 1973 and early in the year, and I met with Robert O. Vernon, who was one of the founders of AIPG. He was a state geologist. I walked into his office, and the first thing he said to me as a young geologist, just had my PhD, and he said, "Are you a CPG?" Well, I didn't even know what that was. And I asked him, he said, "Well, if you're not a CPG, you're not going to work in Florida." So it was the sort of a de facto AIPG exerting itself in the Florida scene as early as '73 when I came in. I had it by July of '73. I had it. When I worked in the legislature in the '70s, we had a PG bill in '75 that put forward the basic tenets of licensure. Georgia was in '76. We were kind of going along with that. We finally got the Practice Act in 1987. I was a chair for the first year. We grandfathered a bunch of folks, and personally, I'm active in 7 states right now as a PG, and I use these webinars and other issues in the teaching as my continuing ed component. A couple of things I alluded to. In the '70s, in '76 to '86, we were jockeying, the geologists in the Florida were jockeying for some kind of a professional status because you had everybody and his brother jumping on the environmental bandwagon, and there were a lot of people doing geology that were not geologists. They were planners or biologists or heaven forbid engineers, but they were all competing for the ear of the policymakers who were creating the environmental laws in the '70s. I was involved in that. We created the board. The board got operational, and it has been part of the business and government role since then. And it's been ramping up, and there's all kinds of stories about that as well. In the late '80s and early '90s, Florida Board helped SBOG get going. And as of count this morning, I talked to Harley Means, our state geologist. He sent me the list. There's 1,626 PGs in the state, and we have 212 geologists in training. The issues in Paradise are many. Where a carbonate platform is full of holes. We have water supply and management issues. It's a continuing issue. We have groundwater pollution from septic tanks and other things. We're injecting our wastewater because we're creating a lot of waste water, and it ends up being injected deep into karst zones. We have solid waste with some leaking landfills that have been problems. We've got the forever chemicals with PFAS in the drinking water. That's a hot button issue that everybody's studying, and the geology groups are interested in that and on it. My area is aggregate, concrete aggregate, construction aggregates, and we've been working on that. There's a shortage. There's issues there just on the availability. We are the largest state. Florida provides about 80% of the phosphate fertilizer in the country. And we have some mining and legacy issues related to phosphogypsum waste that are being handled. And what I really want to focus on today is the coastal erosion and resiliency issues because of sea level change or eustatic changes, and also the karst issues and land development. Professional geology, I think it's the route we're all proud to put PG after our names, which I am, very much so. the grounding of it is the public policy laws and rules that are there to protect human health, safety, and welfare. That's kind of a mantra that you hear in the legislative and rulemaking process. Why are we doing it? It's health, safety, welfare. And that's where it segues to geohazards very nicely. In my experience in Florida, we've been in the consulting business 46 years, and I've been here 51. Geology plays a strong role in the decision process. Not so much in the 70s and early 80s, but once we were ensconced as a profession, more and more of the leadership, political leadership, comes to the community, to the FAPG, AIPG group, and the water resource groups and others that are founded around geology. And they are asking for questions. How do we solve this problem? Why did the problem occur? What are the solutions? What's the solution set? And how do we fund it? And what's the end game look like? And how do we participate? So these are all things that are important that geologists, PGs, need to step up and be part of. The problem we have with geohazards, we got the two main ones in my mind are the coastal erosion issues and the sinkhole karst issues. And it's really driven by population. And I've got another slide I'll show you, but the main issue we have is a term that just came up recently in my lexicon, which is exposure growth. We are growing, but we are exposing the population to these geohazards. And we'll see in a second. I'll keep going here. My favorite photo of the state of Florida images is Florida is really idyllic. When you look at it from space, I've got a bunch of these photos. I got one hanging on my wall here that's almost the same thing. What you see is the peninsula sticking down into the warm waters. It's 870 miles from Pensacola to Key West. And if you want to keep going, you can go another 30 or 40 miles offshore and get to the park out there. But we've got the Everglades, we've got Florida Bay, we've got Lake Okeechobee, we've got the sand ridge that runs up and down the center of the state. We've got the shore over in the West Florida along the coast. The coast over there is just incredibly idyllic, and it's where I personally recreate. My family goes to recreate. These are a couple of personal photos. The one on the left is my granddaughter windsurfing down on the coast down near St. George Island, which it's an estuarine, flat, nice area, beautiful. This is why people come to Florida. The other one is a photo I took down on the Atlantic coast around Daytona a number of years ago, which was kind of a low energy surf and the idyllic picture. People come to Florida because the beaches and the vistas, they're the attraction there, and that is enhanced by people who want to sell them homes, they want to rent them boats, they want to take them on tours, whatever, to see the natural attractions, and there are many. The Panhandle coast where I live, west of here, is still pretty natural. The coast, there's a lot of empty sand areas. And Dr. Beach, that ranks the beaches of the world, has ranked St. George Island, which is my favorite place, as the #1 beach this last year. It's white silica, very beautiful, and there's not a lot of people there. So it's great. The Atlantic coast is different. It's been highly developed, and there's a wall of condos going most of the way down the beach. And that's where you have the high energy and people who are too close in proximity. When the condo development started 60, 70 years ago, there was not a lot of understanding of coastal beach dynamics. And once the first few storms came in and we saw what happened, then everybody threw up their hands and said, oh my gosh, what do we do now? Well, the Band-Aid approach was to put sand on the beach and re-nourish, which works for a while, but it's very expensive. At the end of the story, what is driving all this, of course, is money. The developers and local governments are working. Local governments will give permits for developments. And everybody's seeking economic return. That's the engine that we're feeding, like it or not, that's the engine. One of the things, just sidebar, one of the things I was involved in the early 70s was that the governor at the time, Reuben Askew, wanted a coastal construction setback line and including a flood hazard elevation determination, and that was done. We passed a law. We get beach monuments, coastal geodetic monuments. We had the University of Florida model all of the flood elevation heights, and we came up with an elevation. Well, in 2018, we had the hurricane came through Panama City and St. Joe in that area, Andrew, and it had a 21-foot storm surge, and it wiped out a huge amount of real estate, commercial and home real estate, residential real estate. And I was teaching this geohazards course at Florida State. In the class, we were going over that, talking about it, showing pictures, because we had some really good photos. And I mentioned the flood hazard height and how that was working. And in the back of the room was a lady probably in her mid-30s and taking the class for a master's. She started laughing. I said, "What's the matter?" She says, "Well, I work for FEMA, and I can tell you the system doesn't work." She says, "You may have all these elevations, but the county commissions are granting variances, and most of the homes that were wiped out were built after that construction line elevation was set in 74, 75, and by 2018, they built it out along the beach, but it wasn't high enough. So it was just wiped clean. There was a few places that were built up to 20, 25 feet that made it through. Most of the other stuff just washed away in the storm surge. So that's the flip side of, you try with a pure heart to do things right and provide the information, you do things, but then if it's not carried out, then you have an issue. This is a quick shot. This is Florida as most people view it. When you talk to people come to state, they want to go to Miami, they want to go to Lauderdale, whatever, spring break. But this is wall-to-wall condos, rentals. You can see all the people on the beach. That's the attraction to coming to Florida, is the beach, and it is beautiful. But the downside is we have a lot of people. The system's changing, and it's just the problem gets worse. And when you have the storm come in, you will be wiping out a lot of the infrastructure that's built on the sand. What's driving this whole situation is population. When I got here in 73, there was about 7 million people. And you go to Orlando, and Orlando and Naples were still small towns. They were modest. They weren't sprawled all over the place. By 2000, there was 15.9 million. 2010, 18.8. Now we've got 23 million people in the state. They're coming in over 1,000 a day. But the other component is that we've had to make space for the 140 million visitors who come in, because we have to build the highways. We have to have all the infrastructure to take care of the visitors. And that's what's driving that previous slide. The people who are coming into those condos to live part of the year, to visit, whatever, they are here to occupy space, and they're in the proximity to the coastal geohazards. Here's a good view that explains the problem. I think it's a night view from orbit. It explains the coastal geohazards very well. We've got 23 million people in the bright spots. It's kind of a bright spot analysis. If you look at the light, the heavy intensity is where the sandy beaches are. Where it's dark, it's the estuarine areas and shallow waters that are not so. Farthest down on the Atlantic coast is Marco Island, a little blob of light at the end. The rest of it down to the Keys is the Everglades. The fact is that both coasts are lined with residents, as you saw the previous picture. The access to the state are the interstates. I-95 goes down the East Coast, all the way down to Miami. So what you're seeing there is the I-95 path to paradise. You've got I-75 that comes across and cuts down the West Coast, down towards Naples, then cuts across to Miami. And then you've got the I-4 corridor, which is Daytona, Orlando, Tampa, which cuts across the state. And this is also critical when we look at the karst geohazards. So what's the role of a geoscientist in helping interpret the coastal erosion? Because it's the policymakers, it's the insurance companies, it's the people who are providing the safety net or trying to provide the safety net for people living in these high energy coastal areas. What can the geoscientists do? Well, in my world, what we do is we are the interpreters. We provide the simple models and explanations of the processes, because there is a story that people have to understand before they get this barrage of facts, pseudo facts coming from media. So you will find people come up to me. I've had many people come up and say, "Tom, you're the geologist. Explain this to me." So you have to take the time to explain it. That works at the small scale. It also works at the mega scale when you're talking with legislators or county commissioners or what have you. What you have to do also is describe the energy levels. People do not understand that in the world of coastal issues, the high energy comes in at about 1 or 2% of the total time that we're occupying the beach area. And it's people understand, they look at the statistics, they see the storm events, they see all the tracks, the spaghetti maps coming into the state and all over the place. But they don't understand the periodicity of it, which there is none. They are aperiodic, and the level of intensity. So describing that is important. One of the things that is interesting here, I teach at Florida State as an adjunct, but in the department, it's been merged. It's now called Earth, Ocean, Atmospheric Science, EOS. Atmospheric science is the old school that talks about meteorology. And that's the key. I think the important thing is we're segueing into a professional group that understands a lot of the other issues, and that's not just the sorting the sand or the granite outcrop. It's the whole picture. Then we have to look at the process response model of what happens when you build on the beach and too close to the high energy. You have to be able to describe what those man-made alterations are going to do at the coastal interface, and how do we naively try to stall a geologic processes to our benefit, own personal benefit, or the benefit of people living there. I've had people. I had a lady one time say she came to the beach. It was so beautiful. It was that idyllic look of the windsurfer out there and all that. And she said, "Oh, I wish this is the way it could always be." But she didn't understand the timing of the storms, the intensity of the storms, and what it looks like if you have a 21-foot storm surge coming right in your face and you're living there in a house that's 12 feet above surge. 12 feet below sea level. So those are the things that we have to be able to translate that and explain it in simple terms to people who care, but they don't have the background to understand it. There's also the issue of the rising sea levels. It's a controversial issue. We've got some really good indicators over on St. George Island and to the west of St. Vincent Island. We've got beach ridges that go up 6 feet above present sea level, which were Roman warming period events, the water was 6 feet higher than it is now. So we know it's changing. We know could be fairly rapid. We just have to we have to understand this and monitor it, and we are. There's another component that is being observed right now in South Florida, and a lot of other areas around the country, is the static level adjustments that come from subsidence. We also, if you're up in the North Country, on the Great Lakes, or up in the Hudson Bay, you've got glacial rebound. Well, down here, we've got a down warping. It's kind of a teeter-totter effect. South Florida is actually sinking, and it may be a combination of crustal, it may be karst collapse, there's a lot of things, groundwater withdrawal. But we do know from satellite imagery or satellite measurements that we are seriously sinking. And so, but how is that played? It's played as if it's totally on the sea level rise component, which I think if we look at it, there's multiple issues that are involved. The last one is something that's been an economic issue for the state, is the renourishment sand. Back 60 years ago, 50 years ago, state started to renourish the beaches with sand. Now it's a resiliency component. That's the new buzzword. But where does the sand come from? Initially, it was coming from offshore. Corps of Engineers would permit, dredging companies would come in, they dredge the sand up, pump it up on the beach, spread it back out, and just add energy and dollars to the coastal dynamic by pumping it back up. Well, it's very hard to get permits now, regulatory permits for dredging. So most of the newer projects are upland sand sources. So we're trucking sand from inland 40, 50, 60, 100 miles to beaches at $80 or $90 a ton to place on the beaches. So there's some very, very large projects that are underway that are very expensive, but the sand is coming from in the center part of the state. So it's not just something that's, you go up on the next dune up and put it there, put some sand out there. One of the issues that has been nagging for a long time, and this is what I did my doctoral dissertation on the Great Lakes, was the effect of coastal structures put in by the Army Corps of Engineers, for the most part, which were the jetties and other protrusions out into the littoral drift zones. This is one on the Florida East Coast, up in the Canaveral area. But you have the sand coming down towards you from the north, and you get a buildup on the up drift glacier. The littoral drift zone is accumulating on the north side, and it's being starved on the south side. So what you ended up with was a depauperate lower zone there that was not the natural protection of the bars and everything was removed because of the loss of the sand. When I first came to Florida, they had it called sand transfer plants, where they were picking the sand up on the north side and pumping it to the south side. They couldn't do it in enough volume. It was logistically a problem. So then in the 70s, we went to actual pumping sand from offshore, and then it's gone into the other hauling from upland sources. So the main issues are obstructions to the littoral drift along the coast, and that's what's not understood. So you get people building up way too close to the beach, and then you end up with having to come back in. The main way of doing it today is this is upland sand. You don't see any dredge pumps or any pipes coming in from offshore. This is upland sand. It's expensive. The sand has to meet color and size gradation standards. It's heavily weighted on the 20 to 30 mesh size silica, and the companies find this. The sand companies find it, and they make good money selling it to these renourishment projects. But it's a trucking distance is really a problem. It lasts a short time. This particular beach is just south of St. Augustine. It's been renourished about 3 times in the last 10 years. And it's because you have some very, very high quality upland land ownership. And It's expensive. And I think the main thing is when you come in there, that person who says, I wish this is the way it always could be, you're giving them a false hope that this is going to be this way all along. Because if this area is affected by the nor'easters, they come in there with 60, 70-mile-an-hour winds pounding the surf, and it takes out the littoral bars and changes the slope and really allows the wave energy to hit up against the sand bluff, and it is eroded fairly quickly. But the main thing with the renourishment issue is, in my mind, is it's a Band-Aid approach that gives false hope to the people who want to live on the water. Here's a recent Corps of Engineer project. I got this photo from Bill Ailey, who is a AIPG member and here in Florida. He works for the Corps, but this was up. Can't remember where it was now, but it's up on northeast coast, and they put a big bulge out of sand. This was all trucked in for the most part. There may have been some that was dredged. You can see the dredge pipeline there coming in, but what it does is, again, it's costly. It continues the myth that sand placement's the answer. It also, one of the big environmental issues is it disrupts the sea turtle nesting, which is one of the real knee-jerk issues with the environmental groups. Hold on one second. But what this does in a practical sense is this protrusion out in the water, it changes the dynamics in and around this particular renourishment project. So it's nice that you add a buffer, pushing it out into the water farther, but it also changes the dynamic on the south as to in the distance there. You could have all sorts of unanticipated consequences that because of this attempt to renourish and protect a higher value real estate. Okay, let's move over to the karst issue here in the state. Florida is a carbonate platform. It's fairly young. It's flat. And what is the role of geoscientists? Well, you probably always, some of you have heard, I've always heard this a lot, is that what's groundwater? Well, groundwater is a river under the ground. Well, in a special case in Florida, it can be a river under the ground in the karst conduits, but it's not in most places. It's old-fashioned Darcian flow. But in the geoscience world, what we're again doing is being the individuals who explain how the system works, and then how do we influence, how does the population, how does the interplay work with this karst system. So first thing is understanding the karst system, and then how do we live with it, how do we protect it, how do we utilize it effectively, all of those things. So the big question in many cases is what is karst? I got a couple slides later on that talks about the springs in Florida, but one of the things is that people see karst as a spring system. If you're a cave diver, a scuba diver, you might want to go try it. It's great. But what it is in reality is what the karst is in reality with a spring system is it's a connection to the underground water supply, and it provides a lot of the water for our drinking water needs, irrigation, what have you. And the state is covered with the springs. So if you go online, and the Florida Geological Survey has got quite a bit of information on this. So but what we have sinkholes. That's what people also think. They think of the sinkholes, they think of the catastrophic events, and people don't realize that there's multiple levels of sinkholes. You have shallow ones and you have intermediate, and you have deep ones. They're all interacting in that. You can see them here in the state. Many times you have a cover over the top of a incipient sink, cavern. How do we locate it and avoid it? Well, we'll talk in a minute about the 1981 catastrophe, which focused on sinkholes, and the engineering community and geology got ramped up and began to provide a service to help identify where you had a potential karst issue, and you may want to move your home or do something different on a piece of property. In fact, on our first board in 1987, we had Tony Randazzo, who was the chairman at University of Florida. He took the opportunity then in the mid 80s. He had formed a company called Geohazards, which has been critical in leading the use of geophysics, drilling geophysics to identify high karst-prone areas to avoid the catastrophic sinkhole collapse and loss of structures and economic value, and also occasionally a human life. What are the anthropogenic interactions? Well, you come in, you don't know any better, and you'll construct over the top of them. Okay, we've got the geohazards consulting groups around. There's a bunch of them, and they help find and locate them before you have the problem. You also have greater land subsidence over deep and larger areas, and we'll talk in a second about that. We also have surface mining components that are critical here in the state, where we have some fairly deep, large karst features, where we've had you pile up waste. In the case of Florida's phosphate mining industry, we have a lot of waste phosphogypsum. They pile it in. They're called gyp stacks, and it's piled up. It might be 250 feet high. Adds a different loading on the surface. Also causes some solutioning if the gyp stacks aren't lined, so you'll get some interactions with the carbonate, some acidic reactions, enlargement of the caverns, and we've had a number of serious subsidences where it's cost the companies hundreds of millions of dollars to retrofit and remediate not only the hole in the ground, but the groundwater contamination that goes along with it. So it is a serious component that has to be dealt with from an economic standpoint in the mining industry here in Florida. Also, when you're mining, you can have interactions in the actual pit excavation areas where you'll trigger a karst event. And all of the phosphate mining requirements are that at least in the central Florida, where it's more critical, the workers are trained on karst response. If they're working on the drag line, they see something strange going on in the dirt in front of them, then they react according to a karst plan. So these are things that we've been able to get into the requirements just to let people know what the issues are. What are the benefits of karst? We've talked a little bit already about it. It's the caverns, the fractures, the enhanced groundwater supply, the speed of recharge, the movement. Downside of that is that if you have pollutants getting into it, they also move through that system pretty quickly. I hesitate to say this is a benefit, but we are using the karst zones down 2,500 to 3,000, 3,500 feet. There's a cavernous zone across most of peninsular Florida that's known locally as the Boulder Zone, and it's a cave system, and it has water quality that's about 40,000 total dissolved solids, and it's a good receiving zone for things that you don't want to, liquids you don't want on the surface. You don't know how to get rid of them, so you inject them down into the Boulder Zone in a class 1 or class 4 well, whatever your UIC well, to get rid of it. That's a storage. It's eventually going to come out on the shelf edge at the subcrop for where the units outcrop into in the Gulf or into the Atlantic, but it's a long-term temporary use of that karst cavern. When you get back to the policy and how we interact, go back to the night view of the state, and you look at the I-4 corridor area on the left, and then you go to the right. That's the U.S. State Geological Survey map of sinkhole occurrences for the last 60, 70 years. The dots are where you've had shallow and deeper sinkhole events, and you'll see that it's clustered around Tampa up through Orlando, and then on up towards the north. This area is jokingly known or seriously known as the Sinkhole Alley, because we have such a large occurrence of sinkhole events. We had years about 10 years ago, we had a fatality where a fellow was living in his mobile home and he went to bed and never woke up because his bedroom fell into the sinkhole and dirt came in on top of it. And that's a very rare case. But most of the safeguards that we have in place are set up to try and avoid that. But when you compare the sinkhole frequency from the blue dots and you compare that with the population density from the highlight satellite image, and then you look at the population increase, we're having more and more people coming in here that may not even understand what they're taught, what's going on. So this is again a role for the PG who is working here or advising somebody coming down from Iowa or Pennsylvania to come down here in New York State. Hey, it's nice to go look at the we'll call it Springs Sink. It's nice to go look at Devil's Millhopper over in Gainesville. These are examples, but here's the process. This is what's going on in this carbonate platform. You may lose them pretty quickly, but it's worth. I don't think it's too improper to keep explaining it to folks. I think that the one that was really critical, and this came about, and I think this was the reason that PG's got such good traction by the mid 80s. In 1981, in Winter Park, which is just north of Orlando, we had a very large feature develop. There was a Porsche dealership that lost a good number of brand new Porsches that went down in this sinkhole. A few homes, a warehouse, some other stuff. It's now been redone it's been sealed and it's now a lake, a water reservoir. Very interesting because this was the call out for the population and for the science and engineering community that we need to do something. And they started a Sinkhole Institute. We started gathering a lot more data. The USGS State Survey and everybody got involved a lot more to try and understand and help people avoid this. I've included on this, for those of you who want to download this, a couple of YouTubes. One of them, the first one is, the second one. No, the first one is a YouTube from a local TV station that records this from a helicopter video when it was happening. So if you want to just understand the scope of what happens when a big collapse feature occurs, it's a good video to watch. The shallow karst is what's given us a lot of the terrain in the state of Florida, the surface terrain that people look at. The morphology is depressions with interfluves, and many of the depressions are filled with water. Like this is what called a springs here just south of Tallahassee. It's touted as the world's largest freshwater spring. This watershed goes all the way up into Georgia through a fracture system. The karst investigators have put dye trace studies in here, and the water in Tallahassee that's put in the ground up in Tallahassee, which is 25 miles north of this, will reach there in a couple of days. So it's moving very quickly in there. It discharges to the river and to the Gulf, part of the estuarine ecosystem. But the karst features across the state shape the surface. We have a lot of flat prairies with dimples. The dimples are karst. They're in lineaments, so you can see where they are. You can see that they're fracture controlled. It's all very interesting. A lot of times, we'll go back and look at photographs, aerial images from the 50s, 40s, and 50s, black and white, and you can see the lineaments and help with planning on what's going on with the subsurface. Drinking water, most of the supplies of the deeper superficial from the upper Florida and mid Florida and aquifer systems are from the fracture systems that are coming up from the subsurface, and the round circular shapes are all over the state, and they provide the network of springs. The freshwater springs are a hot button environmental issue. The cave divers, the picture on the bottom there is light coming down into the Wakulla Springs. It goes down about 250 feet and then connects back into a cave system that comes back to the north, all the way up into South Georgia. So the shallow karst is important from a lot of reasons, not only aesthetically, but water supply. The downside of the shallow karst is that it is easily contaminated. The problem we have right now is there are a number of springs programs within the water management district system and the legislative process and the DEP, environmental agency, looking at what is causing contamination. It's septic tanks. We have a lot of septic tanks. We have sandy upper level soils that are letting the contaminants go in untreated. And these are long-term problems. And these are statewide national issues is the spring protection programs. We've got cattle, feedlots, we've got all sorts of things that are causing pollutants to get into the spring system. But it takes the geologist an understanding of how this works to help in the policy formation moving forward. I've also included some YouTubes on this one also to talk more about the springs. Getting down to the deeper stuff, about 8 years ago, Dr. Sam Upchurch, who's kind of the early describer of karst in Florida, along with a couple of other folks, we did a paper on, it was called hypogene speleogenesis, which was the hot acidic water coming from down deep up through the fracture systems and creating large caverns. This is the central ridge area that's down towards Frostproof and Sebring, and you can see the lineaments north and south, the lining up of the rounded structures, the characteristic karst, perfectly round lake is a diagnostic. We see a lot of those from aerial imagery, but when they line up in nice and clustered like this, we realize that in that subsurface, down in those deeper zones, and these are huge caverns that have collapsed over recent or Pleistocene time, at least, to create this system. And the north-south ridge there is a positive geomorphic feature is a sand ridge, and you have these karst features are actually piercing that and dropping out from beneath a zone that has quite a bit of sand over the top. So in order for those to be created, you have a large cavern down the subsurface. I've drilled oil wells, and we've gotten into zones at 2,400 feet to 3,000 feet where you had drill bit drops of 120 feet through a cave. It makes the drilling a problem because you lose circulation, and you have to case through it, and you have all sorts of, and you have that high chloride water that attacks drill pipe and casing, there's all sorts of issues that are attendant to the cave systems that are in the subsurface. I mentioned Dr. Upchurch. Sam was at Michigan State when I was up there in the late 60s. He taught it for years at University of South Florida. Tom Scott was an assistant state geologist. Mike Alfieri is very active, and Tom DeBecke are both very active in geology in the state of Florida. This is the Bible handbook if you want to know anything about karst, because I think Florida is a prototype of what goes on. We have all the combinations and permutations of karst, and it's a Springer book, Springer Verlag. It's not a cheap book, but it's a bookshelf reference that you will use if you're doing anything in karst, because it slices and dices every component of karst systems, shallow, medium, and deep, and talks about how it occurred and how we live with it. With that, that's my slides. I'm glad to take any questions that may have arisen.
Tom, thank you for a great presentation and a really enlightening presentation. What I'd like to do is to have folks maybe drop your questions in the chat. We've got probably 5 or 6 minutes. We can take a few questions here.
Okay.
I'm gonna lead us off. You referenced an occurrence that I taught when I was a geology professor. The gentleman who was killed when the sinkhole opened up underneath his bedroom. That sinkhole, I think, has since reopened, if I remember reading correctly. Is there enough high quality data with respect to first population trends and second sinkhole occurrence to really start thinking about hazard prediction with respect to sinkholes opening up in places as population grows? Can you maybe tell us a bit more about that kind of opportunity, or if that is being undertaken?
I think the opportunity comes back to the county land use regulations that will note where sinkhole hazard areas are and focus and put a red zone over them. And then if you're going to go in there, and you really have to go in there to build something, you've got your level of scientific inquiry is a lot more than if you're on a sand dune upland somewhere. So I think the solution is there. If you haven't been to Florida in a while, guys, you come down here and it's crazy. There's things growing up all over the place. We have the villages in Central Florida, and we got pickleball courts going up everywhere, and it's crazy.
Craig Kimball asks, how serious is the groundwater withdrawal issue?
We've had studies over and over. The water districts, we have the 5 water districts. It is an issue. The problem is one of if you overdraft it, you get saltwater intrusion coming in. They're monitoring that. They're trying to re-inject. We're trying to manage it. That's the reason the water management districts are created, was to manage these kind of issues. But you can easily overdraft. The classic, let's take a second, but we had a cold snap down in Central Florida for about 4 days, and the crops were going to be frozen out. The solution by the farmers is they turn the pivot irrigators on, and they keep the water coming to give a microclimate over the top of the fruits and vegetables. They did that. Within a couple of days, they withdrew under the permits. They withdrew billions of gallons of water. It caused a cone depression. It took the roof support out on the karst, and all along the I-4 corridor, you had small sinkholes developing there. It was hundreds of them, and some of them were right on the highway. They had to go back and close the road and do a bunch of remediation work. But yeah, it's a problem, and it's something that everybody's monitoring right now, because you can't supply the growth without having fresh water.
One quick note to everyone, the link to the quiz for New York State is available in the chat. So that has been posted. This question from Rich Baldwin, what is the source of sand in the Sand Ridge?
Appalachian Mountains over the last 100 million years. All that's, I've done a lot of work up there. You see the silica grains get washed out of the saprolitic material, gets in the streams, gets down to the coast, moves down the coast, and you have the linear trend. We've had sea level bopping up and down many elevations and deposited. Drilling, I've done a lot of sonic core drilling in the ridge area, and you will see some wonderful examples of sorting and quality of silica. Once you get south of Sebring, in and around Lake Okeechobee, you have this huge delta of sand that goes down into the upper Everglades. This was mapped by Tom Scott and others for the Geological Survey back about 25, 30 years ago. And I've done a lot of drilling down there, and it's amazing. You'll have 100 feet of some of the most beautiful silica with no impurities. You could use it for glass sand if you wanted. It's beautiful stuff. But it was all originated over geologic time, coming down the East Coast, one storm after another, and just slowly edging its way down. And you know, it's 150 feet high. You drive across the state and you see a ridge, and you go up over the ridge and down, and that's the Sand Ridge. So it's pretty nice.
This from Kevin Hobson. Kevin says, you mentioned subsidence in South Florida. What counties would be in this area?
Right now, it's focused on Miami-Dade. There's a group of professors from several universities down there: Florida International, Florida Atlantic, Miami, University of South Florida. They've been monitoring the INSAR satellite data, and they've got quite a number of areas that have, we call it the blue dot map, it shows areas where you actually have land surface subsidence that's fairly significant. You know, is this on a crustal level, or is it a local karst level? We know that they're withdrawing a lot of water. It could be adjustments there, but we know that's happening. And it's you have you had the Surfside collapse down there along the beach. That had some karst components to it. It had some erosion components, but there's a lot of issues related to the stability of the subsurface. What it means, frankly, is that the geotechnical engineering on the front end for new construction needs to be a lot more comprehensive than has been done in the past.
This is from Norman Meeks, and Norman, I'm going to paraphrase just slightly here. Norman asks if you could talk a bit about legislature changes with respect to sinkhole coverage in Florida, and especially if you could talk about what it is that's driving those changes, whether it's a financial driver, whether it's an insurance industry driver, or if you know.
It's both. It's from the time that we had in '81, the insurance companies had their light bulbs went off, and they realized that there was an issue, and they began looking at the rating and of risk. So that's been an ongoing component, and you have a number of the science folks we have in the state are working with the insurance industry as experts on these issues, trying to understand, you know, hazard and risk components. What's the driver? The driver is the money. People are losing money. If they have a house they can't insure, and they are damaged, then they take the loss. If the insurance companies come in and they put they have a geohazard inspection, sinkhole inspection. If there's a potential, they put a rider on the policy that you pay through the nose to get insurance. So it's dollars going both ways. You have the same thing with the coastal areas. many of the coastal areas, you cannot get insurance. They created, about 30 years ago, they created a citizens insurance here in the state, which was state-sponsored insurance company. And they would go out and pass the risk off to other reinsurance, safety net reinsurance, trying to give coverage to get people to come down here, because if they bought a home, they couldn't get insurance. You're not gonna buy a $3 million home and have to, not have insurance on it. So it all gets back to the money driver and the fact that people want to be in paradise. They want to see the coast. They want to go to nice places, but there are some inherent risks. And at the end, we've tried to inform the AIPG members, and others have tried to inform the body politic and the legislature and other places that this is what needs to be done. They've pretty well followed along. Then you have the insurance companies doing their thing. So at the end, it costs more to live here because of the hazards.
I do see we have 3 questions left. We're bumping up against a time limit. We'll try to get through those 3. First from Tony Giunta, and Tony, I apologize if I mispronounced your name. He asked, Tom, should we be wary of buying a home in an area where there are several sinkhole lakes nearby? This is common in the Winter Haven area.
No, not if you go in with your eyes open. And you can go in with a geohazards, a geophysical. I mean, you can run ground penetrating radar or something like that across, or you can do some, 4 or 5 drill holes in the area to see if it's, if you have any cracks and seams and caverns, things like that. You can tell pretty quickly. There's a huge amount of literature that's being generated over the last 20 years as these issues have been codified and thought about, and there's been a lot of academic work done on it. So if you're going in and you're advising somebody, you can do a literature search, you can do site specifics, you could have, I'm shilling for Geohazards here, but if you get somebody like company like Geohazards come in, they can tell you in one day with some geophysical testing whether or not you have an incipient cavern under your house or your property that you want to build on. And you can put in some soil, you just put some borings in down into the rock, not just sand and soil borings. You go down into the rock and see what this material looks like, and go from there. Make your decision.
John Lamprecht, and John, I apologize if I mispronounced your name, asks if you could maybe comment a bit more on the anthropogenic components to sinkholes.
It kind of follows on from what I just said. The anthropogenic is, in my mind, is when we as humans interact with the sinkhole complex or a sinkhole prone area, and we don't go in with our eyes open and understand what's going on. And we make business decisions, we make home location decisions without taking, without a due diligence approach to spending our dollars.
Okay. And then I think our last question, and Oswald, I'm sorry we're not going to be able to get to yours. I will, with your permission, Tom. We do have one more question, but I think I would like to forward that to you via email, and maybe if Oswald can send me his email address, we can put you two in contact. Art Becker has asked, geologically speaking, is it the East Coast or the West Coast of Florida that is more stable?
Well, they're both reasonably in terms of the karst or coastal.
I think here probably just geologically. So I think if I were interpreting it, and Art, you can feel free to follow up, it would be just about, generally speaking, East Coast versus West Coast in terms of geological stability.
Well, the West Coast goes from Pensacola down to south, down to Marco Island and into the Keys. It's generally is very stable in terms of the karst. We've got the coastal erosion issues, that sort of stuff, but that's on the edges. But you come inland, it's fairly decent. From Tallahassee down into the peninsular part, it's it's pretty stable. We've got the Sinkhole Alley, which is kind of a misnomer. It's just because that's the aggregation of where we've mapped them. But I think if you're careful, it's a stable area. The East Coast is also probably a little more stable because we don't have quite as much of the shallow karst. But you know, it's all on a carbonate platform. So, and the thing I've learned about working here and drilling thousands of holes is that the geology changes, the facies changes are rapid. And if you've ever tried to explain the term facies to an engineer, it's it's interesting because they don't understand how quickly geologic conditions can change in the subsurface, particularly in Florida.
Okay. Well, with that, I think we will conclude the webinar. Again, I know Oswald asked a question, and if Oswald will email me, I'll try to forward that question to you. So it seems to be something we could talk about for yet a bit. Tom, I can't thank you enough for sharing your time and expertise on behalf of AIPG. I hope that we maybe can convince you to do another one of these at some point. It seems to be very well received.
Okay.
One more time, the quiz link is in the chat, and you do need to complete that if you want your continuing education credit to be counted toward your registration in New York State. I thank you, everyone, for attending, and we'll see you in September.